Okay, in counting problems, order is sometimes important. When order is important, you do a permutation, which is what lesson 10.1 was on. Sometimes order is not important. When order is not important when you're doing a counting problem, then you do something called a combination. All right, so permutations, order is important. Combinations, order is not important. Now, when you do a combination of things, just as you do on your calculator, you can do a permutation and a factorial. Combinations are also found on your calculator. Let me show you where they're found. You go to Math, highlight Probability, and then NCR. That is combinations. Now, combinations are also used when we do an expansion of a binomial using the binomial theorem, and we're going to do some of that today as well. So today we're looking at combinations and expansion of binomials using the binomial theorem. All right, first of all, combinations. The formula, which you do not need to know, NCR, is n factorial over n minus r factorial times r factorial. Now, when you have a combination of items taken a few at a time and a permutations of items taken a few at a time, there will always be more permutations than there are combinations. All right, let's talk about an example now. If you'll look at example 1 on page 690 in your textbook, we have the idea of a standard deck of cards. Now, whenever you are dealing with the sample space of a standard deck of cards, there is a sample space for that on page 690 in your textbook. So anytime you're dealing with a deck of cards problem, you can look at this particular sample set. All right, you have 4 suits. You have spades, hearts, diamonds, and clubs, and you have 13 cards per suit. So that's a total of 52, and we call that a standard deck. All right. In question A, in example 1, we are asked the following question. We are asked if there is a standard deck and we are asked to draw 5 cards, how many different ways can we have a 5-card hand with a deck of 52 cards? So the answer to that is 52 C5. And the reason it's a combination, not a permutation, is because it doesn't matter what order the cards are in, right? It's still the same hand. So 52 C5 on my calculator. I go to Math, highlight Prob, go down to NCR. I do 52, excuse me, and I get this large number, 2,598,960. That's how many different hands I can draw. Let's look at part B of example 1. It says, in how many 5-card hands are all 5 cards of the same color? Same color. In other words, I've got to have all 5 black or all 5 red. All right. Now for this to take place, I have to think about it in terms of counting principle. First of all, I have one of two colors that I can choose from. And then, of my two colors, there are 26 in each color, and I'm choosing 5 of those colors. See how that works? So 2C1, I'll show you how to do this on your calculator. Times 26 C5, and I get 131,560. That's how that works. Okay, let's look at question number, or example number 2, I should say, because example 2 is a little more involved. William Shakespeare wrote a total of 38 plays. All right, 18 comedies, 10 histories, that would make 10 tragedies. Question A is, how many different sets of exactly 2 comedies? And 1 tragedy. Can be read. Exactly 2 comedies and 1 tragedy. So how many comedies do I have? 18. And I'm reading 2. So there's that many ways to do that. How many tragedies? Well, there's 10, and I'm reading 1. So there's that many ways to get 2 comedies, that many ways to get 1 tragedy. I multiply those together using my calculator. I get 1,530. There's 1,530 different ways that I can read 2 comedies and 1 tragedy from the works of William Shakespeare. Now, I will say again, the reason we're using combinations and not permutations is that it does not matter what order I read those in. Order doesn't matter. All that matters is that I'm getting them read. All right, now, the second question here is, how many different sets of at most 3 plays can you read? At most 3 plays. So I can read 0 plays. I can read 1 play. 2 plays, or 3 plays. At most, 3 plays means that I can read it 0, 1, 2, or 3. How many plays do I have? 38. So this is 38, C0, 38, C1, 38, C2, and 38, C3. So these are the different combinations. This is 1, 38, 703, and 8,436. Now, when it's at most, that means that if I chose this one, there's only one way I can do that, 38 ways to do that, so forth and so on. Here, I'm not going to multiply these together, I'm going to add them. All right, so that's combinations. All right, we're going to look at something now called Pascal's triangle, because that's going to help us in evaluating a binomial. And it involves combinations. So we have row 0 of Pascal's triangle is 0C0. Row 1 of Pascal's triangle is 1C0 and 1C1. Row 2 of Pascal's triangle is 2C0, 2C1, 2C2. Row 3 is 3C0, 3C1, 3C2, and 3C3. So this is row 0, row 1, row 2, row 3. This is known as Pascal's triangle. Now, if you put in the numerical values, this is 1, this is 1, this is 1, this is 1, 2, 1, this is 1, 3, 3, 1. Now, another way you can get this is, notice that the first and last numbers of Pascal's triangle are always 1s. To get the 2 here, you simply add these two together and you get 2. You add these two together, you get 3. You add these two together, you get 3. So in row 4, you would get 1, 4, 6, 4, 1. Because if I add these two, I get 4. If I add these two, I get 6. If I add these two, I get 4. Now, these numerical values are going to be important when we expand a binomial. Now, basically what I mean by that is when I take a binomial and I raise it to some power. This is going to be NC0 times a to the n, b to the 0 power, plus NC1, a to the n minus 1, b to the 1, plus NC2 a to the n minus 2 b to the 2. And then you continue this pattern on till you get NCN a to the 0 power b to the n power. All right, the thing to remember here is this. This is what you need to remember, is that whatever this is starts out at this power and it decreases by 1. Its exponent decreases by 1 as you go along. This one starts at 0 and then increases by 1 each time till you get to n. All right, an example is, let's say I have x plus y to the 3rd power. So this is 3c0 times x to the 3rd, y to the 0, plus 3c1 x squared y to the 1st, plus 3c2 x y to the 2nd, plus 3c3 x to the 0 y to the 3rd. This is just a simple example. All right, 3c0 is 1. So this is 1 x to the 3rd, y to the 0, plus 3c1 is 3, 3x squared y to the 1st, plus 3xy to the 2nd, plus 1 x to the 0 y to the 3rd. And then if you simplify all this, you would get x to the 3rd plus 3x squared y plus 3xy squared plus y cubed. All right, notice that 1331, which represents the 3rd row of Pascal's triangle, always goes in front. Now these get a little more complicated when you have coefficients in front of your binomial. Like, let's say I have x plus 2y, and I'm going to do this to the 5th power. So the 5th row of Pascal's triangle is 1, 5, 10, 10, 5, 1. So, since I'm raising it to the 5th power, I do 1, 5, 10, 10, 5, and 1. I do x. I do x to the 5th, to the 4th, to the 3rd, to the 2nd, to the 1st, to the 0. I do 2y to the 0, to the 1st, to the 2nd, to the 3rd, to the 4th, and then to the 5th. Now I have to simplify all this. 1 times x to the fifth times 2y is 2 x to the fifth y. I just multiply that out. Remember, to your order of operations, you always evaluate exponents first and then multiply. All right, here's where it gets a little more complicated. 2y to the first times 5 is 10. X to the fourth, y to the first. Plus 2 to the second power is 4. 4 times 10 is 40. X to the third, y to the second. Plus 2 to the third is 8. 8 times 10 is 80. We have x squared, y to the third. 2 to the fourth is 16 times 5 is 90. No, it isn't. It's 80. And this is x, y to the fourth. And then 2 to the fifth is 32, y to the fifth. Now, notice that when I write this, x starts out raised to this power. So your first term will only have whatever this is in it. Your last term will only have whatever the second variable is. I don't know why I put that y there. It doesn't go there. So x to the fifth, x to the fourth, x to the third, x to the second, x to the first, x to the 0, y to the 0, y to the first, y to the second, y to the third, y to the fourth, y to the fifth. So those increase. All right, so that is combinations and expanding a binomial.